story. This, but that is how it. Okay, switch camera. Are we still live? My Samsung Note 9 or whatever it is totally got buggy and it started saying reconnecting, which is weird. I'm right in the house. Turned off the Wi-Fi and it just still put the squiggly line on the screen forever. Hopefully it wasn't actually live streaming during me messing with that. I totally had to close all the apps and it took about 3 or 4 more tries opening the YouTube app for it to actually even boot up into the app. So Samsung phones are buggy. So how is it going? Hey, is the video stream working now? Is it clear? Hopefully somebody can tell me before I go too far with this. But yeah, so I'm messing around. I'm just tinkering, and I have one of my small VFDs here. So these VFDs, instead of putting AC power into them, you could put DC power into them with the 2 DC power terminals, which I'm using right there. And then just using the 3-phase out. And right now I've got a switch to tell it to run forward, and then I got a potentiometer right there. I was starting to say when the video hung up is that this place is a mess because I've been just tinkering a lot and everything just piling up again. So I mean, I've tried to take toroid coils and like modify them. I tried buck boost ones, and you know, I don't know how to do all the math on it. I just experiment, golden screwdriver as they call it. Just put some primary and secondary windings on there. And sometimes I get lucky, and for some reason I just could not get this. This is a massive toroid from a huge car amplifier. I mean, it was capable of at least 1,000 watts. So, I mean, it was a massive car. I couldn't power that one, but I mean, I probably need a whole slew of MOSFETs for it. So I was running one MOSFET, was getting kind of hot, but now I'm running 2, and I'm going through this little transformer. This transformer actually was a step-down transformer from 120 volts down to, who knows, 30 volts DC or whatever to run a printer. So I'm using it the other way. I'm feeding in the primary and coming out the secondary, just rectifying it into these 2 capacitors. Each capacitor is capable of like 160 volts. So it'd be 320 volts DC, and I'm actually charging this way over 320, sometimes on the high side. Do not want those to blow up because they're going to scare the crap out of me and, who knows, blast in my face. So hopefully that doesn't happen during a live stream. We'll watch the DC voltage there. And then here's a 1-horse motor. Now, obviously, the motor is unloaded, and there's no way of any hopes and dreams that you could ever use this futile of power to run a motor like that with a load on it. But I'm actually just getting it to turn, so it's kind of fun. So I have a switch for the run position, and this potentiometer is going to the input, so I don't have to like change the speed with my finger like in my other video. I'm just gonna be able to flip that and do it. I don't have something automatically making a pulse width modulation. I'm actually using one of my homemade microcontrollers. I really need to put this into a project box because this thing works awesome for experimenting DC power supplies. I have it so I can change my duty cycle and my speed, and that transformer seems to be liking 20,000 hertz, or 20 kilohertz. And the light input, that's from another project I was working on. But I had this made actually to power the duty cycle on my laser, and then it was reading the light input for my another project. But I'm just using it to drive the MOSFETs without using a dedicated pulse width modulator chip. So I'm just doing it manually. You can see if I kick it up, you'll see the deal there. And it's already starting to make voltage, just kicking it on a real low duty cycle, 55 volts. But let's crank this sucker up. I seem to be having to get about pretty high duty cycle to get this thing to make enough voltage to really run that thing. So this is already booted up. It's got 279, 280 volts. And I have to kind of fiddle with the duty cycle over here when I do fire it up because sometimes it can't even get the motor to turn. But I probably got plenty of voltage in the capacitors in there to turn it on. And it's turning. So let's see here, frequency 30, so I think I could swing this thing. Oops, it's real touchy, this potentiometer. 22 hertz. You can hear it clicking. That's it not having enough power. Try to set it down a little bit. It's starting to give me a fault for under voltage. Just stop the run for a second. Let it charge up the capacitors again. Come on, sucker. Sometimes it doesn't like to obey. Once it's stuck in that mode, it won't like clear itself. I have to turn it off. We'll do that. I need to totally shut it off and back on. There we go. This potentiometer is real touchy, and if I jump to too high a frequency, of course the motor just you can't do it. So I think I smell these MOSFETs getting pretty hot. Woo! That burnt the shite out of my finger. That gets much hotter. It's probably going to start desoldering itself. But let me turn it on one more time. And you know, it's running like at 3 hertz. But that is a 3-phase motor. Oh man, see, the MOSFETs are probably not delivering the power because they're hot. So, yep. So I need to shut it down. So manually driving the pulse width modulator by just turning it up and down. Probably that's right. Potentiometer on that, but anyways, yeah, it's pretty cool. I had it running a lot longer than that, but me cranking that up and letting it really pull the current just heated the shite out of these 2 MOSFETs right there. Almost seemed to be working just as good with one of them. So this thing basically, I got 12 volts from this power supply coming into here, which is giving 12 volts to the primary winding. And then the MOSFETs are just, of course, tied between the negative side of the coil to ground, which is the black wire here, negative. And then to drive the MOSFETs. So 12 volts feeds over here into these 2 transistors, which basically just takes the small 5 volt switching pulse out of this microchip and changes it to closer to like 10 volts or so to drive the MOSFETs, make sure they get them driven completely on. And who knows, when it pulls the voltage down, maybe it's not driving on all the way. That's bad. That'll make the MOSFETs get hot if you don't gate them completely. It should be, though. That's always usually worked for me before. You hear all the vibrations? Somebody must be at my front door. The kids are going in and out, and I have my phone set to notify me every time someone's going by the camera. So that's probably interrupting my video. So, okay, so I'm switching the primary, and then the secondary, I have it seriesed. And then it just goes through this, I don't know if this is hot at all. Nope. This full wave rectifier, which makes it foolproof. Oop, I got smoke coming out of that MOSFET. I don't know why it was. Oh, look, it pulled the wire off. See, I told you they would desolder themselves. I shouldn't have even been doing anything, but I might have bumped something. If you break the ground or whatever, and then these are gated partially, they will push crap load of current. So that sucks. Yeah. So going through the secondary over here and then into these 2 capacitors, and you saw over, probably about 300 volts at one point. When I had this, if I don't have that thing hooked up, I don't know if I should do this or not. Like I said, you guys might get to see an explosion. Let's just see what these capacitors kind of charge up to real easily without the load of this bank of capacitors on there. Let's see. I don't see anything on my scope. All right, so something did come apart. Common plus. Well, that thing spazzed out. I thought I heard a weird noise over there. That's probably why that thing was wigging. Still not. Oh, you know what it is? Once one of those MOSFETs dies, it's still. What the heck? Well, that's not good. Maybe something happened to my little microcontroller over here. That'll suck. Huh. I'm not ready to fix that. Let me see. Yeah, I'm no longer getting my pulse out. Yeah, there's something got screwed up here. My chip is not still functioning to the LCD. Well, that sucks. Something did get zzz, but not to quite the explosion I was worried about. Either that or my little something unhooked. Anyway, I'm gonna have to fix that now. We'll be able to run it for you guys again. That sucks. But you saw it spin the motor. And yeah, once you get crazy things like MOSFETs, if they short out, it could short out the transistor, which can in turn short out something else. But I was running it's a 1K resistor between the base of this NPN switching transistor and that chip, so that should I could run that to ground and it wouldn't fry that chip. So I don't know what happened there. Something might just be loose or something, or something got flipped. I don't know. But I wanted to do a little more on the video, but I actually had that thing ramped up to about 10-15 hertz running off this thing earlier, but the thermal I think kind of ran away on this by the time I had you guys watch, so that was cut short. But that's kind of cool, huh? If I could, I'd like to get some maybe a little beefier MOSFETs and put them on a heavy ass heat sink, like something like this heat sink from a CPU. Maybe put like 4 MOSFETs on there, parallel them up. And I'd like to do a push-pull setup through the transformer, but I don't have anything set up for a driver, pulse width modulation. I thought I set up one of these microchips the other day to do what they call full or half bridge. That the microchip says it could do, but it's the secondary output's not mirrored of the same pulse width. It's actually whatever amount of time off the one output is how much time the square wave is on the other output. So if I have it at 25% pulse width modulated, 20% duty cycle, I should say, the other output on these microchips will be at 75%. So that don't work. You need both of them, just oscillating one than the other, but I want them to have the same duty cycle as I turn it up. So who knows? I could probably do something with a divide by 2 IC chip or something, and then use this into it, and then out in the divide by 2 we'll do one bank than the other of a transformer, divide up the current between 2 of these and 2 halves of the transformer, and that might actually do it pretty good. And the other thing I was wondering is how much this transformer would be able to take, but it didn't get hot. So far it's still just the MOSFETs getting pissed off. So yeah, I cooked something for you guys, but it just didn't blow up. No smoke. At least I saw a little bit, but not much. So anyway, let's see what it is. A rat's nest, buddy. If you saw the beginning of the video, it's the first thing I started off about. Again, just to say I was experimenting with a bunch of different toroids I was trying to wind. I had these 2. Oh crap, that stuck to my finger. That was so ridiculous. These 2, and these were just filter chokes on circuit boards, and they were paralleled up or whatever. So I took and soldered together several of the windings to make a secondary, 3 times or 4 times as many turns as the primary, so you get a step up configuration. And then I was doing 2 of them, and then series going through one was driving a rectifier to each capacitor, and then in series, and that was giving me 300 volts. But these things, I want to say the impedance or whatever, I mean it wasn't a good match. I tried different frequencies and everything, but it was just cooking those MOSFETs like right away. So I tried a bunch of different toroids I was making and everything, and then I just took this off of a printer circuit board and just using it backwards, using it to step up volts instead of down, and it's actually lasted long enough to actually power that enough to spin the motor. So anyway, but yeah, this is a disaster in here. And now I got to figure out what happened there. I might have to put my same program into another one of those, which luckily I do have more than one of them. And what I want to do is I need to put it like on a little I need to make myself a project panel so I can have like 12 volt power supply, just plugging pins into it, and then I want to put like embed, like mount one of these circuit boards on there with some maybe some variable things just to turn knobs for the frequency and duty cycle that way. That'll be awesome for my projects. So that'll help me. I got to do that one of these days. So might have to move things around maybe in here and put like a breadboard or one of those little, what do you call those, pegboards or something up on the wall, and just start plugging in shit to it. This room, yeah. I mean, I'm watching YouTube up there. I've got another supercomputer over there for music that I still don't do that much. You know, made a song for you guys years ago called "Goodman Sucks." Yeah, it didn't go too well with the Goodman lovers. Check the current. What are you saying? Check the current. The current. I'm not sure what you mean by current, donut. But, yeah. So, I'm surprised this power supply, but it's a big ass old school 12-volt power supply. It never seems to shut off. It must be able to produce a lot of current. So whatever I've hooked up to it blows up before that thing ever trips. So, oh man. So, all right, guys, this video is probably getting way too long. The action ended too soon, so I'll maybe